Albert Einstein had famously said that if we would know what we are doing, it won't be research. Would it be? Research is all about venturing into the unknown, and therefore roadblocks are expected all the time. How do we negotiate with these roadblocks? In this talk, I will recount my personal journey of research and say 3 strategies that has helped me tremendously in negotiating with the roadblocks that I faced in my research: resist, recast, and restart. Our story begins in around 2011. I have always been interested in studying natural language processing, where we try to make systems that can process human languages and also build models of how humans use languages. So I was interested in how do Indians type on digital platform. And as many of you might be already aware of or doing all the time, we type Indian languages not using Indian scripts, but more often using the Roman script or the English script, which linguists call transliteration. So while I was studying transliteration and the ways, in different Indian languages we transliterate over digital medium like, Twitter or Facebook, and also on, search engines, we saw a very interesting phenomenon, which is that people not only mix, transliterate, but they also mix language. For instance, in these tweets, you can see that people are mixing English and Hindi. Even in search logs, Bing query logs, we saw that people were asking queries where they were mixing multiple languages. For instance, 2013 ka Scorpio ka carrier mein Rashifal. Of course, this is not surprising to somebody like me who has been born and brought up in India speaking multiple languages, and therefore we do code mixing all the time. We mix languages all the time. However, I did not expect that people will mix languages even when they were querying. Apparently, this, which linguists call code mixing or code switching, happens worldwide, in all multilingual societies. For instance, here are a few tweets collected from, various parts of the world which mixes various different languages, for instance, Turkish and German, or Spanish and English, or let's say French and Arabic, and so on and so forth. Since code mixing is so common, therefore, it's a natural question to ask that how to build technology to serve code mixing. Because in multilingual societies, if we were to serve with a technology, then it must actually be able to, process code mixed input data. For the next 5 years, we ventured into this problem. We tried solving many different sub-problems and building tools that could process code mixing. But all through, we faced a lot of pushback. The primary argument for this pushback was, is this an important enough or interesting enough problem to be solved? There are 4 main arguments. Futility, that is, if somebody can mix 2 languages, then the person should know both the languages. So why not they will use only one of these languages while interacting with the technology? So therefore, probably people would not code mix when they knew that the technology can't handle code mix. Then probably it's only, it happens in India, in some limited places around the world, and only in limited context. Then the most ridiculous argument I have heard is what I call the puritanical argument, that, by allowing people to code mix on technology, you are basically supporting this impure use of language. Impure, anyway. And the last but not the least is the trivialization argument, that code mixing can be handled just as a text normalization process. Normalization is when we bring a variedly written text, like let's say spelling variations, into a single standard spelling. So they said code mixing was a varied use of language, as if we could just, do a spell checking, we can normalize code mixing to a single language. We knew that none of these were true. It's not a trivial problem. It doesn't have a limited scope. People were already mixing technology, using code mixing to address or interact with technology. But science asks for evidence. And therefore, we thought, okay, let's try to find concrete evidence to show that all these, allegations or pushbacks are actually baseless. So first we went out to find how much do people code mix. For instance, we looked at Facebook pages of celebrities and found that almost all sufficiently long threads are code mixed, and even the posts, 17% of them were code mixed. Then we looked at worldwide, looked at 7 languages and how people, code mixed across those 7 languages. And we found that 3.5% of, tweets coming in those 7 European languages were code mixed. And unsurprisingly, it comes from all over the world, but to different extent. For instance, in Istanbul, we found 12% of the tweets were code mixed, whereas a place like New York, London, or Houston, only 1 to 2% were code mixed. Okay, so code mixing is rampant globally, but the point is, why do people code mix? Does this give any further clue in processing natural language? Now, linguists have a lot of hypotheses on why people code mix, and we tried to validate some of this over social media. In one such study, we found that when we looked at how English-Hindi bilinguals code mix on Twitter, we found that Hindi, or the native language here, is a much preferred way to communicate negative sentiment, as much as 10 times more preferred to convey negative sentiment, as opposed to English, which was more associated with positive sentiment. In fact, swearing was almost always done in Hindi, and we wrote a paper that we might praise you in English, but gali to Hindi mein hi denge. Now, beyond just the statistics, there is an important lesson here. The lesson is, if we were analyzing data from multilingual society, suppose you are doing trend analysis for a business or a product, and you only looked at data from one particular language, most commonly that's English, and then you will get a much rosier picture than what it exactly is, because most of the swears, galis, will be actually the native language. So not only code mixing is rampant, it is also extremely important to understand code mixed language, because otherwise you will never get the complete picture of what the users are trying to say, both to technology and to each other. So with all these arguments and evidence in our favor, we were able to not only build a strong code mixing research group in our organization, but we also started, this also fueled a lot of interest in code mixing research across the world. So in 2013 or so, you can see in this graph, there were only 1 or 2 papers that were published in premier natural language processing conferences in code mixing. And just within a matter of the next 7 or so years, there were lots and lots of work that were published in this area. Today, there are 2 workshops happening almost every year on code mixing, and there are a lot of different teams around the globe who are working on various languages and various problems within this bigger ambit of code mixing. So here is the first strategy of negotiating with the roadblocks: resist. Research challenges the status quo. Therefore, whenever you try to answer a novel question or answer it differently or try to work on something new which people haven't thought about before, resistance is natural, pushbacks are natural, and we have to build that counter resistance. So therefore, it's important that you find the scientific evidence and try to build a strong resistance. Let's now ask the other important question in research, which is that how do you solve the problem of code mixing? Now, to solve any problem, the first thing is to detect that the problem exists. And for code mixing, it would mean that given a piece of text, I identify that it is indeed code mixed. For that, I have to do word level language identification. For each word in the text, I have to identify which language it is coming from. This is far from a trivial problem because, words across languages might look similar. If you are collecting data from social media, people would do spelling mistakes and you might mistake, word from one language to another language. I already mentioned issues of transliteration, so on and so forth. So we spent quite a bit of time researching on these topics, and we eventually were able to build, code mixing detector for more than 7 languages. Now, why this is also hard is availability of data. As you know, most machine learning algorithms that are used today require data to train it on. That requires labeled data. So somebody need to label the tweets with which languages were mixed there and how were they mixed and so on and so forth. This is quite effort intensive. Now, we were able to come up with an algorithm which did not require labeled data. It was an unsupervised algorithm. So essentially, we were able to build systems in these languages, and we could expand it to any number of languages we wanted to, as long as we just had unlabeled data. But the problem is that at least to test these systems, how well these systems work, we required labeled data. And this itself is a difficult problem because, you had to go to people, maybe crowdsource, to get labeled data. For the 7-language tool that I described earlier while talking about the Twitter results, we were able to collect such data. However, when we wanted to, expand our tool to 25 languages, it was a very hard problem. Because imagine a language pair, Estonian and Malay. There might be a code mix tweet in that, but how do you find a person who can annotate, code mix tweets in Estonian and Malay? It was very, very hard. So we tried really hard and tried doing crowdsourcing, controlled annotation, but it was so difficult to get data annotated in all these languages. So here we encounter yet another kind of roadblock. What do we do? Well, if data was the problem, we thought, can we not generate synthetic code mix data? The idea came from the fact that code mixing is not just random mixing of words from multiple languages. There are well-defined grammar of code mixing, and linguists have studied those, and there are grammatical frameworks for those. So maybe we could make computational models of these grammatical framework, and given a monolingual sentence or a pair of monolingual sentences, we could generate code mix sentence out of it synthetically. So we did again a couple of years of research, at the end of which we were able to show that it is possible to generate synthetic code mixed data from monolingual sentences. But not only that, training classical and neural language models with these data actually improved their performance on code mix task. This brings me to the second strategy of negotiating with the roadblock, which I call recast. Not all battles are worth fighting. Challenges in research often requires rethinking and thinking out of the box, or recasting and reframing your research problems differently. So when you are hit with a roadblock, sometimes you see beyond the roadblock and see novel problems lying there. And you try to redefine your problem differently. And that's how you come up with not only new research problems, but sometimes entire research fields. This is the second most important strategy, I would say, recast. Now moving on, very recently, about a couple of years ago, a revolution happened in the world of natural language processing. We now have something called these massively multilingual language models, which just came up in 2019. For instance, multilingual BERT or XLM Robota, which actually can process multiple languages at the same time. So essentially, these models are trained with running text unlabeled from a large number of languages, as many as 100. And then you train them with just one language, labeled data in one language, and they work across all languages. So we thought, since they are trained with multiple languages, maybe they will also work for code mixing. And several people around the world actually tried applying these models to code mixing, and turns out that they work very well for code mixing. Then we thought, okay, let's further train these models with synthetic code mix data like we did earlier, and saw improvement. Do we see improvement now? Unfortunately, not that systematically as we saw earlier. We did see some improvements, but for some tasks, and the delta was very small. And therefore, with this new technology at hand, it seems like all the things that we have done earlier is simply useless. So again, another Alt F4 moment, and yet another strategy, which I would call restart. So science and technology are ever-evolving field. What looks like an excellent solution today might look lame or useless in the context of the future technologies and innovations. But should we stop? I don't think so, and neither did we. We are now looking at how these multilingual models work and how to make them even more efficient, not only for code mixing, but for other problems. So this, thinking, stopping, rethinking, and restarting your projects and research problems periodically is as important as solving older problems. Every end, be it an end of a journey, a research project, always leads to a new beginning. So I think research that ends gives rise to new research problems. So never stop, keep enjoying doing your research. Thank you.